Alright, so this video we're going to look at systems of linear equations in three variables. And we're going to solve some systems, and then we've got a couple of word problems at the end. Alright, so let's go ahead and get started. So basically what we have, it's three equations and three unknowns. We've got to solve for x, y, and z. Okay. Now, as far as solving these things, there's many different ways to solve these. Okay, you can use matrices. You've got Kramer's rule. You can solve it using with the matrices, the Gauss-Jordan method, and also when I said Kramer's rule, and then also by finding the inverse and multiplying by the inverse of a matrix. And we're not going to do any of those in college algebra. We're going to use elimination by addition. Okay. All right. So it's going to be similar to the previous lesson with two equations, two unknowns. All right. So what we want to do to solve these things is we want to take the first equation, x plus y minus z equals 0, and pair it with the second one. Okay. And then we want to take the first equation and pair it with the last one. Okay. So you take the first equation and pair it with the second one, and then take the first equation and pair it with the last one. Now, do you have to do that? No. Okay. If you wanted to, you could take the second equation, pair it with the first, the second equation, and pair it with the third. Or you could take the third equation, pair it with the first, the third equation, and pair it with the second. Basically, what you've got to do is you've got to choose one of these equations, any one, and then pair it with the other two. I usually just take the first one and pair it with the other two. Okay. All right. Now, what we want to do is we want to eliminate a variable. Okay. So this is similar to the two equations, two unknowns. So when I add the two equations here, add the two equations here, I want one of the variables to go out. So you can choose to eliminate any variable. But the thing you have to remember is whatever variable you eliminate, you have to eliminate that same variable in both of them. In other words, you couldn't eliminate x in this one and y in this one. Okay, you've got to eliminate the same variable in each one. All right, and it doesn't matter which variable you eliminate. So what variable do we want to eliminate? Hopefully you can see that we're going to eliminate y. Okay, so why would we do that? Well, we can see to eliminate y, all we have to do is add them here. We don't have to multiply by anything. So we just add them and the y's go out. Okay. Over here, we'll have to multiply this first equation by what? -2. So we get -2y plus 2y. You see that? So, if you wanted to, you could eliminate the x's, or you could eliminate the z's. It doesn't matter. It's just that the y is the easiest one to eliminate. All right. So let's go ahead and do that. So that's going to give me 4x plus 2z equals -2. Okay. All right. So we've got that eliminated, the y. Now let's eliminate the y in the other one. So for this one, I need to multiply by -2. So I'm going to distribute. So that's -2x minus 2y plus 2z equals 0. And then I've got x plus 2y minus 3z equals -1. And when I add, I get what? -x minus z equals -1. Okay? All right. So what does that do? Well, I eliminated y. So now I have this equation and this equation, and I can pair those together. So 4x plus 2z equals -2, and -x minus z equals -1. Now I have a system of equations like I had in the lesson on 2 equations, 2 unknowns. So now I'm just going to solve this. Okay, so how do we do that? Well, we'll eliminate one of the variables. So let's eliminate z, because all I have to do is multiply by 2. If I wanted to, I could eliminate the x's, and if I did that, I would multiply through by 4. Okay, it doesn't matter which one. So let's multiply by 2, and so this is going to give me 4x plus 2z equals -2, and -2x minus 2z equals -2. And then I add them together, I get 2x equals -4. And then I divide both sides by 2, so I get x equal -2. All right, so there's x. Now I need to know what y and z are. Well, I've got x, so I can take this and I can plug it back into one of these to figure out what z is. You see that? So, I mean, we can plug it back into any one. How about we just plug it back into this first one up here? So that's going to be 4 times -2 plus 2z equals -2. So that's -8 plus 2z equals -2. And so that's going to be 2z equals, and I'm going to add 8 to both sides. So -2 plus 8 is 6. And so I get z equals 3. All right, so there's z. Now I've got x and z. I need to know what y is. So all I do now is I take my value for x, my value for z, and plug it into any one of those, and I can solve for y. So let's plug it into the first one. So I've got -2. I'm plugging the -2 and the 3 into this first equation here. So -2 plus y minus z, which is 3, equals 0. And so that's y minus 5 equals 0, and so y equals 5. All right. So now when we write our answer, we want to write our answer in the form x, y, z. It's a point in 3 dimensions. All right. So our solution would be -2, 5, 3. And that's our answer. Okay. All right. So hopefully that made sense. All right. All you're doing is you're just using the the addition method that you did in the last section on that last lesson. All right. So what about this one? Let's look at our next one. So I've got this. All right. Well, you can see here, I can't do like I did in the previous problem, can I? Okay. I can't do that. So I can't pair the first with the second one, first with the third, because there's only 2 equations. I've got 2 equations and 3 unknowns. So what I want to do is let's just eliminate one of the variables. Okay, let's eliminate one of them. So Well, obviously here we'll eliminate the z. So that's going to be negative x plus y equals 2. All right. Now what do we do? Well, it's going to be similar to what we did in the previous lesson when we got an infinite number of solutions. Okay? It's going to look something like that. All right. So you can see I've got negative x plus y equals 2. Well, if I solve this right here for y, I get y equals x plus 2. All right? And then what I can do is I can take this y equals x plus 2 and I can plug it in to one of these. I'll plug it into this second one here. And so that's going to give me x minus 2 times y. And in the place of y, I'm going to do put x plus 2 plus z equals 3. So x minus 2x minus 4 plus z equals 3. So negative x minus 4 plus z equals 3. And then what I'll do is add x and add 4 to both sides. Okay. And that's going to give me z is equal to x plus 7. All right. So what I'm going to do here is I'm going to have a solution that's going to be in terms of x. All right. So let's see how we write this solution. Now there's a couple of ways that we can write this. Well, if x is going to be, our solution is going to be in terms of x, because you can see I've got y in terms of x and I've got z in terms of x. So x is going to be any real number. Okay. So my solution set would be x. Remember, it's written as x, y, z. Right? That's how we write it. So it's x, y. Well, y is this, x plus 2. And then z, well, z is x plus 7. And then we would write it's the set of all these points, okay, such that x is any real number. All right. And that's your answer. Now, another way that you could write this is you could write it like this. Okay, so it's the set of all x, y, z, such that y equals x plus 2 and z equals x plus 7. Okay, either way is correct. Okay, so that's your solution. Okay, so if you know what x is, so for instance, if x is 0, then a solution would be 0, 2, 7. See, I just plugged the 0 in for x. If x is 1, my solution would be 1, 3, 8. All right. Now, there's other ways that that we could write it. It doesn't have to always be in terms of x. I mean, what if we would not have eliminated the z's? What if we would have eliminated another variable? Then your answer could all be in terms of y, or it all could be in terms of z. And then look at this. If I would have taken this equation here and solved it for x, I would have gotten x equals y minus 2. And then I would have taken this y minus 2 and plugged it in for x, and I would have gotten z in terms of y. Okay? And so then everything would have been in terms of y. And that answer would be correct also. But, you know, you might want to check look at the book that you're using and see how that book's writing their answer, if they're writing it all in terms of X or all in terms of Y or all in terms of Z. My guess is they're probably going to be writing it in terms of X in most of the books. I mean, some books, that's right, they won't write it like that. Okay? But the important thing is just know how to get it. Okay? And you can see here, I just decided to solve for Y. And so everything now is in terms of X. But if I would have solved for X, then everything would have been in terms of Y. And they're all correct. All right. All right. Let's look at the next example. All right. We've got 2x plus y minus z equals 1. Negative 3x minus 3y plus 2z equals 1. And negative 10x minus 14y plus 8z equals 10. So let's go ahead and solve this. So I'm going to take the first equation, I'm going to pair it with the second and the third. Okay, so let's do that. Let's do that here. So we've got 2x plus y minus z equals 1. Negative 3x minus 3y plus 2z equals 1. All right, and then I've got 2x plus y minus z equals 1, and negative 10x minus 14y plus 8z equals 10. All right, so which variable do we want to eliminate? Well, I'm thinking here probably the easiest one is going to be the z. Okay, because if I eliminate the x's, I'll have to multiply this by 3 and this by 2. I'll have to multiply it by 2 numbers, each one by a number. If I do the y's, well, I'll just have to multiply by 3 here, but over here I'll have to multiply by 14. And if I eliminate the z, I've just got to multiply by 2 and then multiply by 8. So the largest I'll multiply here is 8, but if I do the y's, I'd have to multiply by 14. So let's just get rid of the z values. Okay, so for this, we're going to multiply by 2. And so that's going to give me 4x plus 2y minus 2z equals 2. And I've got negative 3x minus 3y plus 2z equals 1. And then here, we're going to multiply by 8. So that's going to be 16x plus 8y minus 8z equals 8. And then negative 10x minus 14y plus 8z equals 10. Okay. All right, so this is going to give us what? X minus y equals 3. All right. And this one is going to give us what? That's going to be what? 6x minus 6y equals 18. All right, so now let's take these two equations and pair them together. So I'm going to get x minus y equals 3. I'm going to got 6x minus 6y equals 18. All right, so let's go ahead and eliminate one of the variables. So let's go ahead and eliminate the x. So I'm going to multiply by negative 6. And so that's going to give me negative 6x plus 6y equals negative 18. Whoop. And I've got 6x minus 6y equals 18. And I get 0 equals 0. Okay? We get 0 equals 0. All right, so for this one, we're going to have an infinite number of solutions. Okay? So what I'm going to do here is I'm going to take one of these equations here, so this is going to be similar to the previous problem. I'm going to take one of these equations here and I'm going to solve for one of the variables. Okay, I'm going to take the x minus y equals 3. Look, it doesn't matter which equation you take, whether you take this one or this one, they're the same equation. Okay, see, if you divide this one here, if you divide it by 6, you get the first one. Okay, so I'm going to take this and I'm going to solve it for one of the one of the variables. I can solve for x or solve for y. I'm going to solve for y. Let's get everything in terms of x. So if I move the y to the right and the 3 to the left, that's going to give me y equals x minus 3. Okay, so that's what y equals, x minus 3. All right, so now that I've got y, let's go ahead and just put a red line under it so we don't lose it in all this work. So now I'm going to take this and I'm going to plug it into one of these 3. How about we just plug it back into the first one? Okay, so that's going to give me 2x plus y, and what's y? It's x minus 3 minus z equals 1. And so I get 3x minus 3 minus z equals 1. And so let's see, how about we do this? We add z to both sides and we subtract. We add z to both sides and we subtract 1 to both sides. So that's going to give me 3x minus, let's change colors back. That's going to give me 3x minus 4 equals z. And so there is z. Okay, so my solution, just like the other problems, remember, it's in the form x, y, z. So that's the point x, y. Well, what's y? It's x minus 3. What's z? 3x minus 4, such that x is any real number. Okay, and there's your answer. All right, so you see, it's not that bad. It's not too bad. All right, what about this one? So I've got x plus y minus z equals 5, x plus 2y minus 3z equals 9, x minus y plus 3z equals 3. So let's solve it. Let's take the first equation, pair it with the other two. Okay, so that is going to give me x plus y minus z equals 5, x plus 2y minus 3z equals 9, and then I've got x plus y minus z equals 5, x minus y plus 3z equals 3. Right? So what are we going to eliminate? Well, let's eliminate the y variable. Okay, all I got to do is add it here. Okay. All right, so to get rid of it here, I'm going to need to multiply this by -2. All right, so that's going to give me -2x minus 2y plus 2z equals -10, and then x plus 2y minus 3z equals 9. All right, and then when I add them, I get -x minus z equals -1. And then here, all I do is add, so that's 2x plus 2z equals 8. All right. So now I've got -x minus z equals -1. Now, if you're taking notes, hold off on writing this down. 2x plus 2z equals 8. Okay, that's this one. Okay, and I know in previous examples I didn't do this. Okay, you can do it or not. It doesn't matter. But I want to point it out here. So we write this down. But one thing I notice is that 2 divides into each of these evenly. And that gives me x plus z equals 4. So what I can do here is I could actually just write this instead of this. And I think that's what I'm going to do, and you'll see why. So that's x plus z equals 4. Okay, but like I said, I'm writing this one, but if you wrote this, you'll get the same answer. What you'll have to do is you'll have to multiply this first equation by 2 to get rid of the x there. But here I've got negative x and x, and I just add them and the x's go out. But not only do the x's go out, but also the z value goes out. Okay? All right. So this has happened before. We get the variables go out. We get 0 equals 3. All right. Is this a true statement? No, it's false. Okay. So this one is no solution. This is an inconsistent system. Okay. All right. So I hope all that made sense. Okay. All right. Let's look at this one. All right. So I think we got 2 more problems to work. Okay. So what they want us to do here is find the equation of the parabola opening upward or downward through the point -1, 10, 1, 4, and 2, 7. Okay. All right. So let's look at this. So they want us to find the equation of a parabola. Okay. Find the equation of a parabola, and they just give us 3 points on the parabola. So what do? All right. Well, we know that the equation of the parabola is this. That's the equation of our parabola. All right. So they're giving us some information so that we can find it. So they're telling us here with this point, let's just take a look at the first point. So they're telling me I've got an x value of -1. And if I take that -1 and I plug it in for x, so if I do f of -1, that's a times -1 squared plus b times -1 plus c, that should equal 10, right? That's what that means. If I plug -1 into my function, I should get 10 as an answer. So what this does is this gives me -1 squared is 1, so that's 1 times a is a, minus b plus c equals 10. See this equation I have? Okay. And then I have f of 1, I'm going to this point now, is equal to a times 1 squared plus b times 1 plus c equals 4. Okay, if I plug the 1 in, I should get 4 as an answer. So this gives me an equation of a plus b plus c equals 4. All right. And then the next one, I've got f of 2 is equal to a times 2 squared plus b times 2 plus c, and that should equal 7. And so 2 squared is 4, so that's 4a plus 2b plus c equals 7. Look what I have here. I've got 3 equations, 3 unknowns. I can solve for a, b, and c, and that'll give me my function. So let's go ahead and do that. So let me just rewrite this down. A plus b plus c 4, and 4a plus 2b plus c equals 7. So I'm going to take the first equation, a minus b plus c equals 10, and pair it with the second one. And then I'm going to take the first equation and pair it with the last one. All right. And I think what I'm going to do here is I'm going to, I could eliminate the b value. Okay, so all I got to do is add them here. Another thing I could do if I wanted to, to eliminate the b, I'll have to multiply by 2 here, but I could also eliminate c, just multiply each of them by -1 and then add. Okay, you get the same answer either way, it doesn't matter. Well, let's just keep doing what we were doing. Let's go ahead and get rid of the b values. And so that's 2a plus 2c equals 14. And then for this, I'll have to multiply by 2. And so that's going to give me 2a minus 2b plus 2c equals 20. And so that's 4a plus 2b plus c equals 7. And then when I add, I get 6a plus 3c equals 27. Okay. Now, I can take this and solve it. So now remember from that last problem that we worked, I can actually take, not 6. I can divide both of these, or all of this, by 3. And that's going to leave me with what? 2a plus c equals 9. And then look here, I can divide this by 2. See, all I'm doing this for is to make the numbers smaller. You see that? That's all I'm doing, making the numbers smaller. And so that's going to give me what? A plus c equals 7, and 2a plus c equals 9. So what I can do here is, how about we multiply this by -1. That'll give me a negative c there. And so that's going to be -a minus c minus 7, and then 2a plus c equals 9. And so that's going to be a equals 2. Whoop. Hang on. Equals -7. So a equals 2. Okay. Now you might be thinking, well, why did you multiply that first one by -1 and then add them? How come you just didn't subtract them? Because c minus c is 0. And that's right. And you could do that if you wanted to. But let me say this. When you start trying to subtract stuff like this, it's real easy to mess up and miss a sign or do it wrong. It's just a lot easier to add than it is to subtract. Okay. All right. So now that we have a, we can find c by plugging it back into one of these. And so I get 2 plus c equals 7. I just took the 2 and I plugged it in there. All right. So if I subtract 2 to both sides, I get c equals 5. Okay. And then I can take what I have for a and c and plug it back into one of these to get b. So how about we plug it into this second one here? And so that's going to be 2 plus b plus 5 equals 4. So that's b plus, let me change colors back to the white. And so that's going to be, let's see, 2 plus b plus 5 equals 4. So b plus 7 equals 4. So b is equal to -3. Okay, so I've got a, b, and c. And this is negative. And remember, my function is in this form. And so we get f of x is equal to A, which is 2x squared, plus B, which is negative 3. So a positive and a negative make a negative, negative 3x, plus C, which is 5. And there is your quadratic function. Okay? All right. So let's look at our last example, and that is a bunch of writing, isn't it? All right. So let's see what we've got here. It says Lionel delivers milk, bread, and eggs to Marcy's camp store. On Monday, the bill for 8 half-gallons of milk. So you got the half-gallon containers, it's 8 of those. 4 loaves of bread and 6 dozen eggs. So you can buy a dozen eggs, 6 of those. Was this amount. And on Tuesday, we had 5 half-gallons of milk, 10 loaves of bread, and 3 dozen eggs was $47.57. And on Wednesday, for 2 half-gallons of milk, 5 loaves of bread, and 7 dozen eggs was $34.72. How much is Thursday's bill for 1 half-gallon of milk, 2 loaves of bread, and 1 dozen eggs? How much is that going to be? All right, so let's look at this. I'm going to see if I can kind of shrink this up a little bit. All right, so I just made it a little smaller. So we're going to have to come up with variables x, y, and z. Okay. So x, in this case, x is going to be price half-gallon of milk. Okay, that's going to be x. Y, we're going to let y equal the price, because isn't that what we're dealing with? Half-gallons of milk, loaves of bread, and a dozen eggs. Okay, so this is going to be price for loaf of bread, and then z can be the price for a dozen eggs. All right, so let's go ahead and get our equation. So this ought to be pretty easy getting our equation. So it says, so first let's just take on Monday, what it says for Monday. Okay, that's this. Let's set up the equation for Monday because it tells us how much it cost. So it says that 8 half-gallons of milk, so that's 8x, 4 loaves of bread plus 4y, and 6 dozen eggs, so 6 times z, and that's equal to $42.86. All right, $42.86. Now let's look at Tuesday. We'll do that in blue, I guess. On Tuesday, we had this. And so 5 half-gallons of milk plus 10 loaves of bread plus, let's see, where it is, 5, 10, and 3 dozen eggs, so plus 3z, and that is equal to $47.57. Kind of looks like a 2 there. That's a 7. All right. And then for the last one, well, it's on Wednesday, it's this. So we've got 2 half-gallons of milk, so 2x, 5 loaves of bread, and let's see, and 7 dozen eggs. And that equals $34.72. All right, So this one, this one's going to get kind of nasty. We've got decimals in there. Okay. Now, I worked a problem earlier in the previous video where we had decimals. And what I did is I multiplied through to get rid of the decimals. Okay. Now, what you could do is you could do that. You could multiply through by 100, and that would get rid of all the decimals. Or you can just leave it like this and work with the decimals. Now, if you have a calculator, it doesn't really matter. You can punch all this into your calculator. But I think in this problem, if you get rid of the decimals, you're going to work with a calculator anyway. Okay? You're going to work with a calculator anyway because the numbers are going to be so big. You've got to realize you're multiplying everything by 100. So this would be 800, 400, 600. Then you got 4,286. Then you got 500, 1,000, 300. So you can see the numbers are going to be real big anyway. And you would have to use a calculator. So in this one, okay, yeah, multiply everything by 100, get rid of the decimals, okay? But I think on this one, I'm going to go ahead and just leave the decimals and work with them so you can see one that's worked by keeping the decimals. And, you know, if you're sitting around, you have nothing else to do, you're bored, pull this problem up and multiply everything by 100 by getting rid of the decimals and solve it that way. And watch, you'll come up with the same answer if you do it correctly. All right. So I'm going to take the first and pair it with the second. So that's 8x plus 4y plus 6z equals 4286. And I've got 5x plus 10y plus 3z equals 4757. All right. And then I can pair the first one with the third one. Okay. And you know something, I think what I want to do on this problem, yeah, you know, this whole video I've been pairing the first with the second and the first with the third. Let's change it up on this one. Let's do it different. And you'll get the same answer. Okay? I don't want you to sit here and memorize, okay, I have to do the first with the second, then I have to do the first with the third. No. Remember what I said at the beginning of the video. Take one of the equations and pair it with the other two. Okay? So in this problem, this is the last one, let's just take the second one and pair it with the other two. Why? Just because. Okay? So let's take the 5x plus 10y plus 3z equals 4757. And then let's take this and pair it with the third one. So that's going to be 2x plus 5y plus 7z equals 3472. All right. So here we go. We're doing something different. Okay. All right. So for the first one, I'm going to need to multiply this by -2, right? All right. So that's going to give me 8x plus 4y plus 6z equals 4286. And then I get -10x minus 20y minus 6z equals, and that is going to be -95.14. And then I add them together, and that is going to give me -2x minus 16y equals -52.28. Okay. All right. So we're good. We're good here. We're on our way. All right. Now remember, you got to eliminate the same variable in each one. So let's eliminate the z in the other one. So I'm going to multiply this one, well, let's see, by what? -7, and multiply this one by what? 3. So that's going to give me -21 and +21. Okay. All right. So hopefully everybody's staying with me. All right. So we've got what? We've got -35x minus 70y minus 21z equals -332.99. And then here we've got, what is that? 6x plus 15y plus 21z, and that is going to equal 104.16. Okay, and then we add, and so that is going to give us -29x minus 55y equals -228.83. All right. So we're getting there. Now, you saw earlier how I said, okay, we can simplify the numbers by dividing through. We did that. Which one did we do that on? Like right here, when I did that. And then I also did it right here. Just made the numbers smaller. All right, so I can actually do that here because, I mean, is it going to make that big of a difference? Well, I think so, because, well, let's just look at it and I'll show you why. Because, see, now I'm going to pair these two up. So what can I multiply to 2 to -2 to get +29? 2 times what? That's not going to be very nice, is it? I'd have to multiply one by 2 and the other one by -29. Okay, and then same thing here with the 16 and 55. But what I notice here is -2, and yes, you can divide through by -2. I can divide everything by -2, and that's going to give me x plus 8y equals, and that is going to be 26.14. And so, yeah, I mean, yeah, we still have a decimal here, but man, it makes this a lot nicer, doesn't it? Okay. Hopefully you're seeing the things you can do. Okay. You don't have to be mechanical about this and do it this step, this step, this step, and this step. Do some things that make it easier for you to solve the problem. Okay. That's the whole point of math, is not to memorize how to work this stuff, but understand what you're doing. All right. So let's take these two. So I've got x plus 8y equals 26.14, and then -29x minus 55y equals -228.83. And so look, now all I have to do is multiply that by 29. You see that? And so that is going to give me 29x plus, and then 8 times 29, that's going to be 232y equals, and then 26.14 times 29, that is 758.06. And then I've got -29x minus 55y equals -228.83. And then we add, well, the x's go out, and I'm left with 177y equals, and that's going to be 529.23. And we're dealing with money, because remember, way back up here, we're talking about that's the price. So we'll round everything to 2 decimals, divide everything by 177. So I get y equals 299. Okay, so that's y. Now I need to know what x is. So I can take this and plug it into there. And so that's going to give me x plus 8 times 2.99 is equal to 26.14. So that's going to be x plus, that's going to be 23.92 equals 27.14. And so subtract that to both sides, I get x equals 2.22, which is $2.22. Now I need to find z. Okay, so I need to plug it back into one of these. I guess we'll plug it into this first one here. So let me go ahead and copy this and bring it down here so we can actually see it. There we go. All right. So let's underline what we've got. We've got x and y. So I'm plugging these into here. That's one I just got from the original equation. So that's, so that is 8 times 2.22 plus 4 times 2.99. And look, and you could have grabbed any one of those equations. It doesn't matter. All right. And so let's see. If I do, I'm going to go ahead and do this times this plus this times this. I'm going to do that all in one shot. So 8 times 2.22 plus 4 times 2.99. That equals, that's going to give me 6z equals 29. Nah, I'm sorry. Plus 29.72 equals 42.86. All I did, I just plugged all of that in my calculator and got 29.72. Okay, so that's going to give me 6z is equal to, so I subtract, that's 42.86 minus 29.72. That is 13.14. Divide both sides by 6. I get z is equal to 219. Okay. So there it is. That's z. Okay. All right. But that's not what they're wanting, is it? You notice that? Did you pick up on that? That's the price of each one. But the question they're asking, how much is Thursday's bill? For 1/2 gallon milk, 2 loaves of bread, and 1 dozen egg. So I've got what? They want to know for 1/2 gallon, 2 loaves of bread, and 1 dozen eggs. That's what they're wanting to know. So I've got, so remember this X here, that represents the price for 1/2 gallon. The Y, where's Y? The Y represents a loaf of bread, the price for a loaf of bread. And this represents the price for a dozen eggs. Okay. And so we want 1/2 gallon, which is 222, plus 2 loaves of bread. So that's going to be 2 times 2.99 plus 1 dozen eggs, 2.19. And so what will that give us? That's going to be, let's see, 2.22 plus 2 times 2.99 plus 219. And that gives us $10.39 will be the bill for Thursday. All right. And there you go. So now you know how to solve 3 equations and 3 unknowns. So I hope this helped. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.